Hello, this is Jarvis Klein, and welcome to session number 4 of our mini project to develop the Aerial Survey Mission Parameters tool. So today we are finally going to work on the main user interface of the tool and the main output of the tool. So coming to our project and going to the maybe just a quick review of what we have so far. We have a main form, that's what we'll be working on today. We have an interface for the user to define new instrument configurations. We have a module, which is the central location in the program where we store and synchronize updates to the list of instrument configurations. We have a custom list view graphical user interface widget or control that lists instrument configurations, and we have a data type for the instrument configurations. So I think what I'll do for anything is run the program and define maybe a hypothetical laser scanner that has maybe a 60-degree field of view, maybe 400,000 points per second, whoops, and beam divergence maybe 0.2, and a hypothetical camera, and this maybe has a 55-degree field of view, and it maybe has 10,000 pixels, and I suppose a hypothetical push broom camera, and this maybe has an across-track field of view of, let's say, 40, and maybe 400 pixels. Leave that clear for now. And now if I close the program and reopen it, because of the work we did last time, we should get those hypothetical instruments back. So now what I would like to do is be able to do some sort of mission planning where I, for example, specify the height and speed that I would like to fly the aerial survey platform, the airplane, and it would tell me, for example, what resolution I would be achieving with each of these instruments, and so forth. So, coming to the main user interface, so if we remember back to, well, maybe I'll just check in with my timeline here. So for today, our goal today is implement the main user interface with the main input options and begin on some of the output calculations. So if we remember back to our first session in this series, we spoke a little bit about our design vision for the program, which was that the user would enter certain parameters. We said the user probably for sure is going to enter the speed that the airplane will fly, and will enter, for example, the terrain elevations, because there could be varied elevation of the terrain, but the so when you talk about the flying height of the airplane, you have height above sea level, and then height above the maximum terrain, and height above the lowest terrain. And we said that there will be different modes for the way the user will input. Basically, you have multiple parameters, and you can assign some of them as inputs and some of them as outputs. So you'll have multiple modes where the user will specify certain inputs and then get the outputs based on that. So the most simple, or the basis case maybe, is that the user specifies the, for example, the flying height, the speed, and the flight line separation. And then we will solve for what that would result in for each instrument, what it would give you for overlap of each instrument, resolution for each instrument, and so forth. Or we may have the user specify the flying height and the speed and pick an instrument and say the amount of overlap he wants for that instrument. Or a third mode might be the user has in mind that he wants to achieve a certain resolution for a certain instrument, and then we'll solve for the height, and if the user specifies the overlap, then we'll solve for the flight line separation. So that's just a review of our idea for this program, and we're far enough along now we can start implementing that. So I think I'll start by putting some radio buttons so the user can define what input mode he wants to use. Maybe we can call this, what is my font size on this form? I guess I'll keep it as 9-point default. So here we have radio button. Could possibly just call it mode, but let's see. Or solving mode. Let's see, radio button. Is this sorted? C radio button. So, this will be, let's say, input flying speed, flying height, and flight line separation. And we'll have another input the flying speed. We actually said we're going to, in all cases, make the user solve for the provide the flying speed, but I guess we'll leave it open. Maybe in the future we allow to solve for the flying speed, but I guess I'll include it nonetheless in each description here that will everything the user will be providing as input. So flying speed and let's say the height and overlap, desired overlap for selected instrument, for a selected instrument. And another option will be, the user can do this iteratively, so the user might if the user is trying to solve for multiple instruments, he might input information about one instrument and use that to do another calculation to refine what he wants to do. But here's what we'll provide the user to be able to do in a single calculation. And the last one that we'll think about providing for now is he inputs the flying speed and desired resolution and overlap for a selected instrument. So this should be a nice tool actually, because otherwise you're just working with spreadsheets probably. I haven't seen software that allows you to define your various instruments and then do these kinds of calculations in a convenient way. Also, in all cases he's going to be entering information about the terrain. But let's see. So maybe I need another group box for terrain. I'll just try this and see how it works out. Terrain and flying height. I don't know, let's see. But for sure I want minimum terrain elevation and maximum terrain elevation. maybe this will just be a terrain parameters. Minimum terrain elevation. So I want to allow the user to define this either in feet or meters. So let's say that here we have it in, as annoying as it may seem to someone who, promotes using the SI system, in aviation, they primarily deal with elevations in feet, even though distances are likely in meters or kilometers or nautical miles. But they use feet for the elevation. But still, for some of the planning work, you probably still want to refer to maybe meters elevation. I did not mean to do that. So let's see if this is edit terrain elevation feet, and this is just label terrain, label terrain minimum elevation, I guess. Label terrain maximum elevation. Oh, what's the right way to order these? Maybe it would look better. Well, if I arranged it this way, what do you think? Feet in meters. I didn't mean to do that. Because, in one sense, the minimum comes first, and layouts in forms are usually top to bottom, so in that sense, the minimum elevation should be on top. But in another sense, it might be kind of intuitive to the user that the value, because the maximum terrain elevation is going to be a larger value than the minimum elevation, that maybe the maximum terrain elevation should be on top. So to sidestep the issue one way or another, I'm just going to put them side by side like this, and then maybe actually like this. How would that be? This might look okay. Something like that. So, train minimum elevation. Label train maximum elevation. Edit terrain minimum elevation in feet. This is the label. It's the right hand side, so I'll just say that. Then we have the edit box for meters. So when you edit one, it'll just update the other. And then we have edit terrain maximum elevation in feet. And maximum elevation in meters. So what's gonna be next? I think that should do nicely. Uh, I would like I would like to have a we put this button on here where the user can click to edit. The user can click here to edit the instrument configurations. I would like to have a little bit of like summary information on this main form about how the instrument configurations are defined, and I'm thinking of making it a text box that just gives a text paragraph form summary of the instruments, and then you would click to edit those, so that you can just see at a glance that you have your instruments defined as you expect. And I may think about just seeing how this looks, I guess. Readout, instrument, configurations. With this now is going to be an edit button. Edit or define instrument configurations. How's that? I don't know. Would this look semi-okay? Looks kind of ugly actually, but what are you gonna do? Whatever. Guess I should just say standard label identifier format name. Let's see, read only. In all cases, the user's going to enter. Well, I guess. Okay, so you've got your terrain parameters here. Then you have maybe. Let's say that he chooses this case. So what would that look like? Then the user's going to additional input parameters, but he's going to enter, the flying speed. Now this flying speed is actually another thing that has maybe 2 units. So actually let me copy this, because you might want the flying speed in knots. I don't know. Well. Alright, flying speed. In knots. Should save this. Or maybe kilometers per hour. That should be enough options. So edit flying speed knots. I mean, I may come back and redo this because we have different input modes and I haven't decided yet exactly how do you switch between them as far as the user interface goes. We may do something similar as we did when defining instrument configurations, but for the moment, let me just maybe get the basis case to work. Flying height, which is again going to be So in this mode, the user is going to specify the height. So I tell you what, we'll make him enter flying height mean sea level relative to sea level. And he can do that either in feet or meters. But we will give feedback, which is going to be the height above the minimum terrain and the height above the maximum terrain. So if the user enters this in feet or meters, then we'll say we need some feedback, maybe like this. Guess maybe it can be unlabeled, but we'll just say it's read only. And so if we make the user specify the flying height above sea level, that's good, but we want to make sure the distinctions are clear and that the user knows. Because, you know, when you're defining the mission parameters, what you're sort of interested in is the flying height above the ground. But from an aviation perspective, because, you know, you're more interested in the flying height above sea level. So if what you really want is flying height above the ground, but then it's complicated by the fact you've got min terrain elevation and maximum terrain elevation. So I think it's maybe the most elegant way to handle this is the user will just be forced to enter in the flying height sea level, but he can immediately see what that elevation gives him relative to height above the minimum terrain and height above the maximum terrain. So maybe this is actually a two-line output little window. Do we have enough space to make it 2 lines? Let me see. I don't want the scroll bars, do I? Maybe neither. And here we say read only, and we say, you know, text flying height feedback. Then the last thing in this input mode is flight line separation. And this, I'm sorry, I'm just gonna go with meters. Just go with meters. Feet is, as I mentioned, is used in aviation in the elevations in the vertical axis, but I haven't seen anyone using it in the horizontal axis. So let's see. Flight line separation. I guess just in meters directly. It might make sense to specify kilometers as well. Should I say meters and kilometers? I guess it wouldn't hurt. We're doing everything else as a set of 2. It's a set of 2 boxes. So what's one more? Flight line separation. In meters or in kilometers, I guess. So how does this look? You know, these probably don't need to be quite as big as I've made them. Made them 78 wide. What would it be if they were all 60? And if I had a value in here like 10,000 feet, certainly not going to go into 6 digits, but how would it look if it were 5 digits? So it should be okay. So with that extra room, let's just see. I mean, I'm not thrilled about the way I'm laying out the user interface. I may come back at some point and make things more precise, you know, pixel perfect as far as their layouts and relative layouts, but then again, maybe not. Let's see. 700 and... So I'm just thinking what resolution I want for this form. Could probably go a little more than 700, but probably not too much bigger. I don't know. But then, so here's the feedback for your flying height above ground. So this would be one kind of complete set of input parameters. However, we have multiple modes here. So I think what I'll do is try to figure out how we will accommodate that. And it may be that we do something similar as we did in our other form, which was that even though the user is not going to see a tab panel presented to him, but just for convenience of working within the designer, we created a tab panel so we could lay things out, and then we just programmatically manhandled it a little bit so that the user would see whatever whatever group box in particular we wanted him to see, depending on what instrument type he clicked. So I might do that again, as it seemed to work okay. I guess so. We'll just get that out of the way for a moment. Here's kind of our hidden tab panel. Designer convenience is what I'm gonna call this. And this one goes in here. And then we'll have another. So let's just look at what the next input mode would look like. For the next input mode, we're going to have Speed, okay. Uh, Flying height, okay. And desired overlap for a selected instrument, so we may be a little short on space here. What that would look like. Just if I give us a little more space. Is maybe I could pull the flying speed out because it's common to all the modes we have so far. If I made this window bigger, what to do, what to do? Well, let me just see how I want to put this on here. I mean, we compile just fine, right? What I'm going to want is a custom combo box that the user can select an instrument from. And since the combo box is going to list instrument configurations, I think what I will do is have a custom control for it. I guess I can put it here under the main form, which is where that custom control is going to be used. So instead of a list view custom control, we now have a combo box custom control. And this is going to extend from our custom. And what do we put inside of it? I guess an instrument configuration. So I have a base class called combo boxed that is a generic version that accepts a type, an item type. So when the user selects something, we can access that selection directly to the object, instrument configuration object that it represents. And ed is just an old syntax of mine, or an old convention of mine, meaning that it's kind of templated going all the way back to C++ terminology. But let's see. Well, it also makes sense to turn things into a verb. You boxed it up in this case. Anyway, I don't know. Let's see. So I forget actually how this works in particular. Sure, we'll need but then what do we do with it? Do we have a member variable? Let me go look. C combo box. Okay. So the selected item is going to be the thing, so you would say the item itself, well, rather, it would take a list, the combo box would take a list of instrument configurations. So, tell you what are we doing here? Refresh instrument configurations, which takes a list of instrument configurations. And then object collection. So what would I do? Would I clear it and then add them all? And then what is it going to do? Is it going to call toString on it? Can I specify the toString function? Refresh items with persistent selection by value. This is probably what I should use, rather. Yes. I believe it's just going to call toString. Or let me look at the base class because I may have done something with that. What is it? What is it? Look at this, pulling up the local help, which is unusual. Everybody just goes to Google, but I still use the built-in help. Combo box is the base class. This might be too slow to bear. Guess I could just Google for this. String method, I mean, it's combo box text. Combo box. Alright. I'm looking for example, what it does to get the string for an item. So I think you can define what function it calls to get that string. Because I'm just not too big a fan of overriding the toString method. I'd prefer to write our own toString method, because, you know, this is a specific case of stringizing one of our items to display in a combo box, but you may have other situations, other contexts where you want to turn it into a string. So just in general, you should at least be able to choose what toString function you're going to use. But don't exactly see it. So there's maybe one more thing I'm going to try, and that is just for example, what is this? Get text, what was that? Who knows? Is Google going to help me? toString method. That's not what I want at all. Value member. This is what I was looking for, I believe. What is it? What is this? Display name. What's that? Hey. What is this? What do we have here? We have a value member. So I don't know why .NET help couldn't tell us. I'm in the wrong place. Ugh. Just looked right, but it wasn't right at all. And here we'll find value member. Is there a display member as well? Value member. Do I still not find it? So was it not in that version of the .NET framework? Ah. Really don't know why help is being so unhelpful. Value member changed. Value member. The description that really doesn't make sense. A string representing a single property name of the data source property value or a hierarchy, blah blah blah. Default is the empty string. Anyway, let's see if that works. What, just by name I'm gonna refer to this? That isn't that great. This is, why don't I call it, for example, just using the instrument name. Rather, then over here we refer to that. Synchronize this property name with usage in. So whenever I have a situation like this where one thing needs to refer to another within the source code, but it's not actually linked in a way that the compiler is going to catch, because for example in that case we're using a string literal to represent a property name, then I like to just make a comment as far as you know, if it's not otherwise obvious in the source code, then you just need a comment to say how things are linked to get together. Let's see. How will that work? Just refresh. We have a refresh function. So this is the function I'm going to use to refresh the list of items in the combo box, and it's kind of funny what's going on here, so let me point out what it's doing. I need actually two comparison functions. So I'm going to go write two comparison functions for my instrument configuration, which I believe as of now has no comparison functions. I guess I'll go ahead and write the comparison functions close to where the member variables are defined. But I still need to break the window up, don't I? Public static int compare by value and compare by object reference, I guess. I don't know, I guess maybe there's some object compare. Oh well, it'll be illustrative, even if there were some other alternative to writing this function ourselves. Compare by object reference. Just directly. The direct object reference. So, comparing by value, we can go ahead and, this'll take a while to write it out, but that's okay. And compare instrument type equals I guess I can just say convert the instrument types to integer and compare them as integer. So that should work if they're not the same instrument type. And return the comparison based on that. Then actually compare by reference is probably not. I probably just want compare by name here, really. Yeah. Actually, what I want is just compare by instrument name. Don't actually need this. But I'll leave this as a stub in case we ever want to implement that function. But what I really want is compare by instrument name and compare by object reference. These are the two comparisons I want. Compare. Should we do case insensitive? I guess just to compare. I'm gonna do one thing, which is a property on our instrument name. So canonically it's supposed to be trimmed, so I'll do the same thing for our instrument configuration class as we did for our kind of user editable instrument configuration class, which is to make this property. So compare by instrument name. And compare by object reference. Otherwise I have no total ordering of them, I'll just arbitrarily. This is not the most consistent comparator, but it will suffice for the usage that we need it. So what I'm doing is when you are going to refresh the list of instrument configurations, you want to refresh the contents of the combo box. And it may be that you are updating the list in a way that the new list is the same as the previous list, in which case, can I refresh? What I'm thinking is, can I notify it that it needs to call the toString method that it's using on all the items again? So if the item object were updated to have a new instrument name, we would want to make sure it gets updated. So why don't we do that? I think that's what we want. I'm structuring the combo box class here to be similar in structure to how I've structured the list view, and I just don't work with combo boxes as often as I've been working with list views in code of late. So, but what I'm thinking is that when you come in and you say that the combo box needs to update its list of instrument configurations, we will tell it to refresh the list of instrument configurations that it already has. I assume this will update the toString, the display of the string that represents that item, but keep the same object reference. Then I'm only going to update the object references if I actually need to, which would be if they aren't actually the same object references. It could be they're going to be the same object references, in which case all I really needed to do is this, and not actually clear everything out and repopulate it, because that's kind of a little hiccup in the user interface if you clear it and then repopulate it. And then, even if you do clear it and repopulate it, it would probably be handy if you select the same instrument that the user had selected before. And kind of the simplest way to just recover what instrument did the user have selected is probably to choose it by instrument name. Now that wouldn't work if the user did an edit in which he renamed the instrument, so you could imagine doing something more complicated, but it should be convenient and good enough that if we do refresh the list of objects in the combo box, we restore ourselves to the previous selection by matching instrument name. And there's an infrastructure to do all of that in this single function call, which is why there's going to be two comparisons involved. So let's have a look at what these are. I need the updated item list, which is this, and it wants it as an array. So I guess I'll give it as an array. It wants the comparison to see whether it needs to clear and repopulate the items in the combo box. So, actually, does this call refresh items, I wonder? Does this call this? I would like to go check. Is it here? Probably should. This probably should call refresh items. In which case, I won't do it here. Presumably this refreshes the chosen toString method on the items in case we don't change the item objects. So I won't do this. I'll just do the single call. And the test for whether it needs to swap out, rebuild the object, the items in the combo box, whether it needs to repopulate that, is the comparison by object reference. So if it's not the same object, then to avoid any chance of anything becoming inconsistent, we just repopulate the list, the combo box items. But then if we do that and we want to restore the user's selection to what he had before, then we want to compare by instrument name, which is going to be that. So that should do it. And I'm going to go ahead and test that at that point. We should compile, I believe. So I will add this new combo box class to our form. We should be able to find that control type here, combo box. Just say selected instrument. Anyway, doesn't matter. Combo box, instrument. Redo all that later, just want to see. When our program loads up, we're probably going to have a refresh or initialize controls function, which is just how I like to structure. It's just something that gets called in the onload function. But we are going to this will notify everyone, right? Alright, when the instrument configuration list changes, then refresh them. So where's my instrument module? The list that I can access, which is this property we did last time. It just specifies we can access the list, but we shouldn't write to it. So we will honor that constraint. Let's see what we get. See if our custom toString method works. Indeed. So that seems to work. So the user can now select an instrument. So I guess we can get back to designing our user interface. Oh, but I wanted to just demonstrate. So if you look at this combo box, I have this hypothetical camera selected. If I go in and, for example, just change the value of that camera, we should see nothing happens. It doesn't even repopulate the box. But if I add a new instrument, or if I just reorder them, so say I take this, I cut it, and I paste it, oh whoops, I paste it right before the camera. Did that work? Cut, paste above. Oh, does that not work? That's annoying. Anyway, that swapped. So now my camera is the third item, and if I look at what's happened in my combo box, I still have the camera selected, but it handled the fact that the objects have been reordered, so it did actually have to handle that by repopulating the combo box, but it kept my selection because it matched it by the name. But why is my cut and paste reordering not working? I have to take a detour to go look at this now. Unfortunately. I mean, did I implement it right? Let's see. Here in my menu handlers, or I guess those menu handlers are actually coming from the list view themselves. Yeah, this is above, says, this is backwards. If I want it to go above, this is again just me getting confused between thinking of something in a top to bottom way or thinking about something in a oh, by index I mean after sort of means increasing index, but in this case it means the prior index. Really, I think I had these swapped from what I want them to be, just because I was thinking about it in the wrong way. So I could say, to make it more clear, I could say above, i.e. prior, and below, i.e. subsequent. So if I had named them this way, well, it's a little heads up about thinking about them correctly so you don't get backwards. I think that will now work. So if I cut the push broom and paste it after the camera, oh, come on. What just happened? I want to make sure I've rebuilt everything. This is rebuilt. And this is rebuilt. And what do we get? The push broom gets cut and pasted below the camera. So what? I need to debug this. Let me do it. Oh, look at that. That would be a problem. Paste above i.e. prior, paste below i.e. subsequent, right? And then the before given position. If it's after, it's adding. If it's before, yeah, anyway. Going to clear my throat off screen for one. Alright, we're back after a short break. So, where were we? Was I still testing to see that insert works correctly on that list box? On that list view, rather. Let's see, cut. and paste. Okay, good. Cut, paste. Okay, good, good. So back to where we were in our user interface. In this mode, the user will be specifying flying speed, flying height, and he will choose an instrument and specify the overlap that he wants. And I'm going to let the overlap be specified, I guess just as a fraction. There was, I'm trying to remember because I was thinking about this before, there was one other case in which the user has kind of two ways to specify something. I guess it's, in this case, he wants to specify speed. He chooses an instrument. He says the resolution he wants. Then he maybe also has to say whether he wants that as a minimum resolution or maximum resolution, which is confusing terms when you're talking about resolution, but nonetheless, and overlap. Oh, yeah, I'm remembering what I was thinking about, which is if the user is in this case and the user is specifying the overlap and resolution he wants, he also needs to specify, if he has chosen a laser scanner, whether the resolution he's specifying is relative to a single pass of the airplane, or can take into account multiple passes of the airplane covering the same spot, which would increase the resolution for laser scanning if the overlap is greater than certain inflection points, such as 50% or 67% or something. So that's what I was remembering. I guess in this case, he just selects the instrument and the desired overlap. So let's go ahead and do that. Ho ho ho! Restart Visual Studio to solve a Winforms problem, as we have been doing from time to time. Oh. So the user selects an instrument and needs to specify the overlap he wants. So how are we going to arrange this? As a percent, I suppose. I kind of want to provide a good long combo box in case the user has given the instrument a long name. So, I don't know, it's kind of ugly in a way how it's laid out, but what you gonna do? I just want to make sure we have enough room on the user interface for every case, and the third case is probably going to be the biggest, require the most room. So let's have a look at that. And I guess the closest thing to it would be to copy from the second case. This is the benefit of this tool, having multiple ways the user can choose his inputs to figure out the parameters he wants. And in this case, instead of a height being an input, so this will free some space in the user interface. Choose your instrument and specify the overlap and the minimum resolution you want. So let's see, if you want a certain resolution, and this is also different between LiDAR and cameras, because for laser scanning, your resolution is sometimes specified in points per square meter, or can be specified in point separation, whereas if it's a camera, then it's probably just you know, a resolution of pixels on the ground. But let's see. So we may need two boxes, and we may just hide one if it doesn't apply. Desired resolution. And let's also give some radio buttons to say whether we are talking about when the user specifies the resolution. At best, i.e. Over highest terrain point, or he specifies the resolution at worst over the lowest. So I guess by default we should have it be selected at worst. Maybe I'll switch these around. Or another one would be average, but whatever. We don't need to overdo the options too much. This should be okay. The resolution is going to be, just say units here, and then here's an alternate way of specifying the units if that applies. So programmatically, this will need to be, the label name will need to be updated. And then he'll specify the overlap. I guess I need another. You know, in the odd occasion, I actually miss the old MFC, the old designer in Visual Studio prior to the Winforms designer and everything else, where your radio buttons had a property you could set to indicate their group order, and you could say, you know, this starts a group, and this would be in the same group as that. And then, if you had another group, you just put them on the same user interface and specify by the group ordering whether one starts a group or not. You could have multiple radio buttons and multiple groups of radio buttons in the same panel. But as of .NET, the way it works out of the box, so to speak, if you want different radio buttons to be separate groups from each other, you actually need a separate panel for each one. So that is the reason for me pulling out this panel, although I guess I could hide the panel, or make it have no border, or just instead of using a group box, I could use a panel. C panel, I assume, LMNOP. So here's another set of radio buttons. And I guess it applies, again, this is a set of radio buttons that may apply if entering laser scanner at worst. And this is after considering multiple coverage. How do we phrase this? Multiple coverage. I guess it could just be a checkbox actually. After considering let's see. But I kind of want a big long label, so after taking multiple passes into account, if overlap greater than 50, how do we phrase this? If your overlap is high enough that you cover the same spot on the ground more than once, it effectively increases your resolution. I guess what I could do is have a little checkbox. I'll just call it after taking multiple passes into account. And I'll have a little box to explain this in more detail. Is it gonna fit on a single radio button? Is it gonna fit on a radio button? I suppose we can make that work. Oh, I'll do it on 2 lines. Why not? In which case I have my little label. So I need room for my info box anyway. I'll show you that. let's add a little info box. Where is our info box? Just say. So this is just a special class of button that for convenience just allows you to specify from the designer that when you click the button a little message pops up, and we'll just say at left specify desired resolution to obtain from the instrument. Then specify whether you want to achieve this resolution from a single pass of the airplane, or whether, if the overlap is great enough, consideration can be taken into account. Let me write it so I can see what I'm doing. At left, specify desired resolution to obtain from the instrument, to achieve with the instrument. Specify whether you want to achieve this resolution from a single path of the airplane, or whether, provided overlap is coverage from multiple passes may be considered, which so as to increase the resolution. For example, if overlap is greater, whether to consider total resolution, total number of points per square meter is doubled with root 2 increase in resolution, point space resolution. If greater than 67%, the total number of points per square meter is tripled after considering overlap. Thus, specify whether, relative to the resolution you wish to achieve, whether to obtain it from a single pass or whether to obtain it considering multiple passes, if any. Hopefully that pretty much gets the point across. Now, because I'm going to enter such a long message, it's probably going to generate a resource file and put it in the resource file, which is a little annoying, but doesn't really hurt anything. Maybe I'll have another label. From each single pass. or allow taking multiple passes into account, or achieve specified resolution from each single pass. That should be clear. So, okay. I believe that is all of the input elements I want on this user interface. So let's see if we can arrange it semi-nicely. So here, I don't know, let me just call this, the user won't see this, but mode 1, mode 2, mode 3. So in mode 1 up here, specifies speed, height, and flight line separation. So the Y position of that is 49. For here it's 52, 42, 45. So this is just down by several pixels. And this one is down by about 4 pixels. And a big flying height advisory. I guess that's okay for this mode. Over here we've got flying speed, flying height. Select your instrument and specify the overlap you want with that instrument. Maybe just a little label. Specify the overlap you wish to achieve with the selected instrument. Maybe I'll make the text on that smaller, so it's just a tip. So it's like that. Let's see. Each one of these tabs has a group box in it. No, I did not put a group box in that one, but I sort of wanted to or meant to. Yeah, I probably need the group box. So, all this stuff, just save it first. Oh, and that's not what I wanted to do. Undo that. Unhighlight this. All this stuff goes inside the group box. Then the group box kindly comes up and gets everything back for us. So all of these group boxes, I'm just gonna put them, for example, location 1, 1. guess we finished from that layout. Then the layout here. This needs to come up 34 versus 34, 37. So up by 3 again. This, just lay it out by eye. I guess it's okay. Then this guy. Specifying, should I call it mode 1? Specifying flying speed, flying height, and flight line separation. Specifying flying speed, flying height, and chosen instrument overlap. Overlap for selected instrument. What did we say? Specify flying speed, desired resolution, and overlap for us for selected instrument. Something like that. Guess I can trim this a little. So let's see, that's pretty low. So mode 3 is the biggest, both in, oh no. Not in both axes, but that's okay. Feel like saving it again. So we come out with something like this. Something like this indeed. Um, 28. just move this down since we do have the space from the other input modes. One, two, three, four, five, six, 7. Maybe I can do that. Maybe I can do this. Just rearrange things a little and save a little space as well. So, with all of that laid out, you may be wondering, where's the output gonna be? When the user enters in the inputs, where does he get the output? And I'm thinking to just make a report, which will probably open in another window after seeing how much space on the user interface the inputs take up. So, it's probably just going to be that the user clicks a button and what? Generate report. Perform calculations, generate. It's wordy, but I'm gonna make the button big enough. Button, perform calculations, generate report. What did we say? Basically, there's the big button. So, I guess in the end I may leave this tab panel so as to, when the user interface is complicated enough, I don't want to do too much wizardry in the programming side of it to rearrange things. And it may actually help the user contextually to see what mode he's in, and he can just switch back and forth if he wants. So I'll just synchronize these radio buttons to the selected tab page, so if he changes this, it'll change there as well. And one question that I have is, in the cases that for example, flying speed is shared among all three of them. So I wonder if I should synchronize the value of these flying speed text boxes amongst all three, and then the flying height is similarly shared. And then there's an overlap field as well that is common to some. Then there's selected instrument. So how much of this do I want to share between modes? I just don't know. guess I won't bother doing synchronization. The user will just have to enter the parameters again. I don't really like that because it would be easy for the user maybe to enter it here, then switch to another mode and not remember to change it. Yeah, you know, if he changed it here or something. Or it's redundant to make him enter it again. Because the flying speed, for example, really is common to all three modes. But I just don't know a graceful way to really handle the whole thing, so I could just when he changes tabs, I could have a little prompt come up and say, do you want to transfer the values that are in common? So if I wanted to do something, maybe that's what I would do. So I guess I can go ahead and get started actually wiring this thing up. So maybe just from the very beginning, top to bottom. Should I put this here or here? I don't know, here's a nice big button. So, oh well. So, from the top, this is a group box, not a radio button. Group box input mode with radio button input mode 1. You could just say mode 1. Input speed, height, flight line separation. Mode 2, input speed, height, desired overlap. Mode 3, input speed, desired resolution, desired overlap. Stretch my legs a moment. And button edit instrument configurations. Group box terrain parameters with edit terrain minimum elevation feet. I guess we did this already. Minimum elevation meters, maximum elevation feet, maximum elevation meters. Ho ho ho. Read out instrument configurations with the label. Then coming down here, tab, panel, mode is okay. And why don't I call it, mode is okay. Then for the pages within the tab panel, where's my collection? Let me call it tab page mode 1, mode 2, mode 3, I guess. say? Should I call it calculation mode? Oh well. How would it look? We've got plenty of room to label the tabs. Don't know if I prefer it or not. But this at least can be consistent with the space there. Alright, so then within each tab, here we've got a group box, calculation mode 1, with, oh my goodness, this is going to be edit mode 1, flying speed knots. Label right hand side, edit mode 1, flying speed knots. Edit mode 1. Why don't I just call this flying speed kilometers per hour. Edit mode 1, flying speed. Edit mode 1, flying speed kilometers per hour. With the label. And this is a label. Label mode 1, flying speed. So then, edit mode 1, flying height, MSL feet, then the label, then edit mode 1, flying height MSL meters, with the label, and a label here, mode 1, flying height. Then we have a text box, text mode 1, flying height feedback is fine. Flight line separation, edit mode 1, flight line separation meters, with the label. Edit mode 1, flight line separation, kilometers, with the label. And this is label mode 1, flight line separation. Alright, mode 2. What did we call the group boxes? Calculation mode 1, calculation mode 2. So hopefully it's clear what this program actually does at this point, now that we've got 3 different ways of entering the inputs. Alright, this is going to be similar. I want to sort of match what I used here, but it's just going to be mode 2. So let me see what's the best way to do that. basically, I'll take these and the flying height, all this stuff. I just want the names. Just want the names. So this one, bother. I don't really need labels. I'll do the labels myself. But instead of mode 1, it's just mode 2. So flying speed, knots. That's this guy. Y. Edit mode 2, flying speed, knots. There's nothing else by that name. Edit mode 2. Oh, it has a colon at the end. It has a semicolon. Then, with that, label on the right hand side. Label mode 2, flying speed. Label mode 2, flying height. Edit mode 2, flying speed, kilometers per hour. With the label. Edit mode 2, flying height. In meters. With the label. And I'll just change it myself here to feet. With the label. Selected instrument. This is combo box mode 2. Selected instrument. With a label. And this is flying height feedback for mode 2. Here's edit mode 2 desired overlap as a percent. So then we have the label on the right hand side for that. And the label on the left hand side for that. And just a note, label mode 2, specify overlap note. Moving on to mode 3. We've again got our flying heights and so forth. Oh. Let's go back to my designer. Take my mode 2 stuff. Take my mode 2 stuff. Replace the semicolons. Get rid of the labels. Clear out the noise. So maybe that'll be useful. Let's see. mode 3 flying speed. Mode 2 is now mode 3. So I still don't have it. Oh, here it is. Knots. And the label. And kilometers per hour. And the label. And a flying speed label. Label mode 3, flying speed. Selected instrument. Let's see the combo box for that. Combo box mode 3, selected instrument. With the label. Should really save this. What else? The overlap. Desired overlap percent. With the label on the right and a label on the left. Then we've got edit mode 3 resolution. Desired resolution units 1. I don't know. It's somewhat generic, so with the label. And again, but units 2. With the label. And resolution is going to be label mode 3, desired resolution. I could go ahead and specify this. Desired resolution units 1, i.e. pixel size for cameras, point spacing for LiDAR, for laser scanning. So that's units 1. And the label's going to be programmatically updated, so that's why it also has and then units 2. So what did we say? We said it looks like this for units 1. For units 2, it's going to be i.e. points per square meter for LiDAR. And I'm just remembering one other thing that I maybe omitted from the user interface. I don't really think I want to add anything more to it, but there is another thing that I did have in mind, which was, and let me just look at mode 2. If it is a camera, okay, it's only in mode 3 that we talk about resolution. If it is a camera, these labels might be different. If it's a camera, there's the possibility that that the x and y axis of the pixel dimensions of one pixel are different. I mean, the pixel might not be a square, and if the pixel of a camera is not going to be a square, which is the case in some hyperspectral cameras, then when the user specifies the resolution, what resolution is he really wanting to specify? And maybe there's another... Maybe I reuse this, because this right now only applies to LiDAR. Maybe I reuse these buttons. And I could even only show these if that instrument does have a different or non-square pixel size. So yeah, that's probably what I'll do. If we get that far. Alright. Okay, this radio button mode 3, resolution mode, or elevation mode, I guess, because I want a common name for both of these. Desired resolution is over lowest terrain. And the other option, desired resolution is over highest terrain. And then we come to these guys. Radio button mode 3. Resolution mode, I can maybe call it. This is elevation mode, and this is maybe resolution mode. Just call it mode A, which is for LiDAR. Take multiple passes into account. And over here, radio button mode 3, resolution mode, mode A, which is for LiDAR. Don't take multiple passes into account. Consider resolution from single pass. And these will have an alternate meaning if you select a camera that does not have square pixels, is my plan here. I need to name this panel. Panel mode 3 resolution mode. And info button mode 3 resolution mode. And this is going to be programmatic at this point, so this big long message is going to be programmatic because I need 2 versions of the message. again and again. And finally, oh my goodness. What? What did we say for that? Okay, that's evidently what I said. What? Specify whether, relative to the resolution you wish to achieve, whether to obtain it from a single pass or whether, if any. I meant to just say if any. So anyway, this is the label for this. For LiDAR, take multiple passes into account. For cameras with non-square pixels, use bigger pixel size. Use longer axis. Or geometric average, or what? Kind of want 3 boxes, which is geometric average, or smaller, or larger. Maybe I'll just allow the choice of the longer axis or the geometric average. So this now, for LiDAR it means that. Use geometric average. I might swap those, but that's the idea for now anyway. So I'll just call this RB mode 3 resolution mode label. And label what just happened? Mode B and mode A. Is that all clear? Calculation mode 3, resolution mode A, and so forth. Finally, button perform calculations. Alright. So I think we have named everything on our user interface. Should we see? I don't see anything not labeled, not named, so that's good. That means we can start hooking up program logic. So maybe I'll start with tying together the radio buttons and tab panel. There's going to be quite a lot of logic here, but well, let's get started. I'm going to rename this. So it's now called button edit instrument configuration. It has an event that was named when we hadn't named the button, but now we will name the button, and its event handler, rename it in the designer as well. we've done enough work. I'm just going to go save my source files. So I really would not want to redo that user interface for any reason. My source. I'll just copy my whole source. Don't need this zip, do I? This could have gone into my source zips folder. Meanwhile, this just gets copied. And all right. So, initialize controls. Let me add, I guess, a refresh. Well, no. Let me just add handlers for each of these. If he checks that one, or if he checks that one, or if he checks this one. Actually, these aren't the handlers I want, I'm sorry. I want this handler. And this handler. And probably still has stubs in the designer that have been removed. Oh no, so it understood that. Okay. And then if he changes the selection of the main tab panel, selected index changed, that would do it. So let me just bracket this off to say that this is mode synchronization between radio buttons and tab panel. And if he checks mode 1 from a radio button, then we want the tab panel to go to index 0, I guess. Otherwise here you want index 1, and here you want index 2. Let me just check if that works. Pow, pow, pow. So that goes ahead and works. It changes my focus to the tab panel, and I kind of prefer keeping the focus on the radio buttons. Just a minor annoyance, but do that and then set the focus back to the radio button. Sets the focus. See if this works. Mode 2, and mode 3. What is this? really like how all the radio buttons are all meshing together. So I'm going to rename just these as calculation mode. Calculation mode 1 and calculation mode 2. And calculation mode 3. Oh, that's fine. So I'll rename these handlers as well. Ho ho ho. Alright. Calculation mode 3. So now, let's see what happens. If I click here, I stay my focus so it allows me to move up and down with the arrow keys and flip through these, which is what I wanted. However, if you click here now, I want it to work in rather the other way. So I kind of need a set selected index without event, and I'm not sure I do have that. So you know what? I have got to go add to my custom controls infrastructure a set index without event capability, which I have similar capability for most of my other control types. For example, a text box. If I want to set the text on a text box without generating a text changed event, I can do so. And now I need where is this used? Clear selection without event. Let me just search for without event. Oh, select index without event. Yeah, so I do already have the feature that I want. So let's use it. Oh, what was it called? Ah, I'm in the completely wrong thing here. Don't know why I thought I was in the right thing when I hadn't navigated to the right thing. But still, I might copy some of that because that displayed the logic that I wanted. But where are we? Tab panel. C tab panel. Alright, well let's copy some of the logic I was just looking at, which is so we've got this enable, just enable item checked event. This is going to be bool enable selected index changed event. And then we have a function that's something like this. Just laughing at my own comments. One of the things I did is implement the ability to see what tab was previously selected. in my derived version of a tab panel. Let's see. Local stack. Or base. What do we call this? Set selected index without event. Well, I can sign it with my date. Arg. And then set it back to what it was. So what we have here is just, we'll do some handling. So what we've done here is we are already deriving, or we're overriding the function that is called when the tab panel has a selected index changed event. So within the tab panel class, it calls this function, and the base class implementation fires the event. So if I've just added a selected index changed handler somewhere in a Windows form, it's the base implementation of this onSelectedIndexChanged function that will notify me. So if I want that notification to not occur, because that's the function I'm trying to write here, which is set selected index without event, if I want that event notification to not occur, I can override the handler here and simply not call the base class, because the base class is what's going to trigger that event for the listeners. And I have my own parallel infrastructure here where I'm calling my own delegate to anyone who is registered to listen to this particular delegate, but it's basically just a parallel implementation of the same thing, so they'll both work in the same way. If we have temporarily disabled generation of that event, then we won't invoke it. And what I'm doing is I just have a member variable where the caller can control whether he wants the event to be generated or not with this member variable by setting it to true or false. But if you just want, as a one-off, to set it without generating the event, I just wrap that here in this function by setting it to false, calling the function, or setting the selected index. And then I could potentially set it back to true, but it could be that it's been sort of globally disabled, or maybe the user has already specified somewhere else that it should just never happen. So instead of setting it to false and then setting it back to true, I know I want to set it to false regardless, but then I'm going to just set it back to whatever it was before. So the terminology I used is kind of just pushing a value on a little stack, just using, it is actually stack memory here because it's just a local variable of the function. So just pushing it on a little stack, putting a new value of false, and then popping back to the previous value on our stack, so to speak. So anyway, that should compile. And now when we switch back to our thing here, the reason we're doing all this is if the user clicked the radio button, I want to change the selected tab on the tab panel, but I do not want to then generate this event, because this event is going to set the radio button, and that would be a little circular, as well as it might end up messing up my focus handling that I'm putting in, so that the focus stays on what the user is actually clicking at the time. So anyway, let's try it. without event, without event, and without event. So now, somewhat conversely, if the user clicks the tab panel, I want to synchronize that to the radio buttons. So if tab panel, this is really tab panel calculation mode. And tab panel calculation mode. If the selected index is 0, that's mode 1, radio button calculation mode 1, set checked without event. It was a little more explicit when I wrote that one. Without raising checked changed event. And it's true. Else if selected index 1, then it's calculation mode 2, and finally, if it's 2, then it's calculation mode 3. And I may do something again where I try to set my focus to keep it on the tab panel, but let's just see. So if I click there, it goes there. If I click here, oh no, I'm keeping my focus, so no need to do anything there. So that's working pretty much how I want. You know what I may do? Because I am not manually specifying the position of anything, I'm going to implement some automatic form resize behavior, and it's just a lazy way of making everything scale itself as the form is resized, which I often do when I'm designing a form. So I'm going to take a small detour to do that next, which will just take a moment. Just set everything to have what I have called a automatically initialized template layout. Bool auto template layout, yes. Bool use auto template layout, yes. And I specify it for the main form, and I specify it for group boxes. And I specify it for tab pages, but the tab pages are going to have to become members of my subclass for the tab page class. So we have tab pages here. I want to replace, throughout this entire designer window, I want to replace this with, I believe this is going to be correct, hopefully. So yes. So now that they are my subclass, is that true? I may not need that, but I'll put it here as well. This one, and this one. And this one. And just pretty much all of them. Well, to show you what that will sort of look like, things will just sort of automatically scale themselves. However, it's not functioning properly within these, and I guess the reason is if I just dock this to the whole thing, I wonder if that would work. If I dock it everywhere, no, anchor rather. If I anchor it everywhere, will that work? Let me see if that works. Yeah, so that pretty much works. So, it's just how I like to implement that the user can resize the form if he wants to, and things just get a little bigger. But anyway, so I'll go ahead and do that. This also needs an anchor everywhere, and this one needs an anchor everywhere. So how's that? Then I need to figure out what the next thing is I want to wire up. So I guess that the next thing, just moving kind of top down here, is terrain parameters. So when the user enters a value here, I just want to synchronize, for example, this with this. So we'll have a new little section of our form, which is for terrain parameters. Synchronizing text boxes. Little brackets, little kind of convention I have for making little blocks of code is I use a brace inside a parenthesis, inside a comment, which is also something I'm not sure I've seen. Other programmers do, but I think it's useful to say when you're starting and closing a little section. So I just want text changed handlers, basically, for when the user is doing it. And we will make it not cyclic when we do our update from one field to the next. So let's see. If the user enters a minimum elevation in feet, then we try to parse that. Minimum elevation feet. I will allow negative values. I mean, it could be negative, in fact, for a terrain elevation. Terrain below sea level is what that would logically be. And if we could parse it, then we want the same value in meters times meters to feet. So let's go ahead and get that. Meters per foot. We're just going to say 1 foot equals 12 inches. 1 inch equals 2.54 centimeters. So we're going to return from a foot is 12 inches times that in centimeters, in meters rather. 12 times 0.254 meters, 0.0254 meters. What is it? Yeah, so 1 foot is 12 inches times 0.0254 meters per inch, and that's the right number. 0.3048. 1 foot is 0.3048 meters. So I guess we'll just return that constant directly. 0.3048. The value in meters, meters per foot. And now I want to set the value with probably the same number of significant digits as we had in the original. And I've been thinking about this lately, and it's a common enough thing that I should write into our library a function to do this for us, which is, you know, if I try to put this in the text box, it's just going to have a million digits. If I could try to round it, but I don't want to round it to some arbitrary number. I want to round it to the same number of significant digits as the user provided when he specified the number of feet, subject maybe to some min and max. So we sort of did that before, but well, let me write it here and then I'll put it into a library routine if I can. So the number of significant digits is how do I want to find the number of significant digits in a real value? Do I have anything? So let me get the number of, well, that's not exactly what I want. I should look at, from the original text that the user has. How do I want to do this? Round trip. Well, let's just see. Wtil, my Wutility class. Get num digits in two-string representation, I guess. Get num digits, i.e. significant digits, in two-string representation. Argval. I guess the way I'm going to do this, not being a wizard at handling, you know, real values on any kind of binary level or anything, I'm just going to say base 10 string equals, and I'm going to count the number of digits in it. So what the heck, why not? Is numeric 0 through 9. Num digits equals 0. I mean, arguably, if it opens with a 0, maybe that's not significant, but I don't care. I will treat it as significant. Sorry, num digits. And I guess while we're here in this library, we could write some type of function that says get toString with given num significant digits. It's basically the function I want. I could say VD is just a little suffix that says the first argument is the value and the second argument is the digits. So I sometimes do little things like that, just kind of mnemonic helpers maybe. Anyway, that's what that is supposed to represent. And so to do that, I want to round, but rounding doesn't work that way because I want to consider the integer portion and the number of decimals portion. So see, if I try to round, it's just going to ask me about the decimals after the decimal place. So what I want to do is handle the int part separately. So it looks like we were doing some of that just here, in fact. So there's the int part. Num digits in int part equals, maybe I have an int util for that. Get the number of digits in base 10, good. Then remaining decimal digits equals the num digits in the int part minus arg num and then we have a choice here. I could say if remaining decimal digits is less than 0, just set it to 0 and return the argval. Rounded to the remaining number of decimal digits. So the thing is, I am mainly thinking about, sorry, this is a string. I am mainly thinking about number of digits after the decimal. I mean, technically, if I have a value and I say that the number of significant digits is 3, and the real value is something like that, well, then technically, if I want to reduce that to 3 significant digits, I would say 827,000. But really, all I'm trying to avoid is not having more decimal places than is really called for. So maybe I should just qualify that in the description of the function name, except write all digits in front of decimal, before decimal. In front of decimal. I don't know, it's wordy, but I want to just point out that this is the function I'm actually writing. I'm not going to, in this function, we will only worry about truncating decimal digits, not about converting, converting whole number parts to 0, a number of places to 0. I.e. the following, i.e. we won't round the number to 827 even if num significant digits is 3. And I assign that with my present date. So that's basically what we've done and what I wanted. So now we have our value in meters. We're going to set the we're in the minimum train elevation now with meters. We'll set the text without event so that we don't cause an event handler loop. And we'll just say toString with the given number of significant digits, which is here's the value. The number of significant digits is justified into a minimum maximum. Let's say minimum 0. Well, I guess no need to do that. Let's just say digits, num digits. Well, right, I do want to have a minimum here. If you're going from feet to meters, it shouldn't really matter because the feet should have a greater number of significant digits. But I still want to put this to a floor to say I don't want to output a number that has like one significant digit because that's just, let's say, a minimum of 2. And then otherwise we use the number from the feet representation. So does that make sense? Don't know why I don't see highlighting of my closing parentheses, but let's see if that compiles. One more parenthesis, perhaps. And, you know, I guess I can be a little silly about this. Probably you would just round to meters without having any decimals at all. I could probably just do that, but let's say 3,000 feet, okay, is 914.4 meters. So whether there's any benefit in the fact that I added this 0.4 or not, maybe not, but it's what I like to do. If we had 10,000, okay, well, that worked out perfectly, but I guess usually it's just going to round to one decimal place because that's about, well, let's see, 9,000. Now that's interesting. There's 4 digits here. This should round to 4 digits, which should not include anything here. So let's check out what happened. Let's check out what happened there. The number of digits in 9001. Oh, 9001.0. Uh-huh. So I need a little more handling in my function. Let's see. Should I start from the back and exclude zeros? Maybe that's what I'll do. I mean, I could exclude both opening and trailing zeros, as I sort of hinted at. I guess that's what should be done, isn't it? Alright, well, in that case, let me do it this way. And exclusive. Exclude trailing zeros. And, you know, and if this were going into scientific notation, this would still not be handling it exactly right. I would want to just go unto the, if you had a scientific value notation like 1.0, how does it even write them? I've forgotten. Whatever, but, okay, message box. 1, 2, 3, 4, 5, E27, 2 string. What does it look like? Okay, it's just E plus 29, for example. So the number of significant digits would really only be up to the E. So I'll take the 2 string and I will trim trailing zeros and E's. How's that? Base 10 string, index of any, I guess. Well, find first. Oh my goodness. Index of E. Oh, crud. Index E. Index big E. Little e. And index E. Oh. It's the minimum of either, assuming they aren't 0. Ho ho ho. If index little e not equals -1, or index big E not equals -1, let's see. E and if index big E greater than or equal to 0 and index E is -1, or index big E less than So this is pretty pointless, but it's just insulating ourselves to whether it has a big uppercase E or a lowercase e, and then just for rigor, even though it would never happen, but I choose whichever one comes first if potentially there could be more than one, which there wouldn't be, but it would just bug me not to implement it this way. So I said, here's this, here's that. Should have just done index of any, shouldn't I have? Index of any, but I didn't want to make an array. And oh well. I wanted to duplicate the behavior of index of any without making our own array, because it's kind of pointless. Could just write our own index of either character. Index of either character. Index of either character is really what we want. Here's my date. You know, if I don't know if we have null handling or not, but int in equals arg string length. I don't know what the overhead of accessing the property is. Since it's just a little utility function, I can write it efficiently, as efficient as C# gets anyway. How's that? So after all of that, this is really what I wanted. The base 10 string is there. We have the base 10 string. Not that. We have a little e, or we have a big E. Right? So from the beginning we have int I, the end exclusive index for our iterator, is equal to the string length, but if the index e is, not equal to -1, then that is our end index. Then we will exclude trailing zeros by taking that end index while it's greater than 0, I suppose. And if the one prior to it is a 0, then decrement. Otherwise, just break. And so it could go all the way down to 0. But then let's see. I don't know if I want to exclude opening zeros or not. I feel like not, just because. So int I equals 0. Then, while we are less than our I and exclusive index, we count our digits and return the digits. So how's that? Yeah, we don't need that anymore. Let's see. 10,000 feet. Whoops. Stop, whatever. I didn't mean to edit. I did not want to edit and continue. Five digits. Okay, well, yeah, it's exact. So 10,000 is exact. Then 999. I get. Why do I get 5 digits when I shouldn't? Let's try it out. What's happening? Oh, I did not actually exclude trailing zeros, did I? Or I just need to. Um, well, that sort of should have worked. Let's see. Step in. So here's our value. Okay, 9998.0. The string for that is just 9998. Our exclusive index is 4. We start at 0 and count up. So our num digits is 4. Anyway, then coming into here, we want to round this to 2. Ah, I said min and I wanted max. You know what? I do that and it's horrible. And the reason I make this mistake is because I'm thinking of a value with a floor. So a value with a floor is really taking max of either one. And I should really write a version of this that just says value with floor, which I guess I have done. Value or minimum, which kind of more expressly represents the semantics of what I mean. So take this, subject to a minimum of 2, for example. I mean, all of this might seem kind of pointless handling the way we round to certain numbers of digits when we should probably just have no decimals at all, arguably. But I'm just not a fan of rounding errors. I want that 1 digit. Or if we have 10 feet here, then maybe I want 2 digits. But so what's happening now? What is happening now? Step back out, go back in. 1 or 2. Why did it say, ah, right, I really can't trail, I can't crop trailing zeros. I can't do that at all. Only up to the decimal could I do that. So anyway, the problem was in another place from what I thought anyway. So I don't need this. And the two-string representation is not going to have a dot zero for no reason. I was just looking at it in the debugger and saw that, but actually the string won't have that. So remove that. Basically. All right then. Oh my goodness. Yeah, probably 1, 2, 3, 4, 5, 6, 7. 7, so that was right. Then what happens next? I get 7 or a minimum of 2, I return 7. Then what happens next? ToString with 7 digits. So the int part of this is that, the number of digits in it is 1, the number of remaining digits is -6. Okay, I took this the wrong way. I took that the wrong way. Oh, what can I say? I took it the wrong way. Is that an intutil function? Where was that? Wtil. Here we are. One more try. Here we go. So can we finally enter some feet? Ah, I don't want to do that. Breakpoint. Can we finally enter some feet in a way that seems reasonable? See, that's all I wanted. And you never know the way people use the program. I mean, in this case, it probably never happened, but maybe someone wants to do the calculation relative to some unit that who knows what it is, and they're putting in the unit in the meters field, but really it's they're using kilometers or something. You just never know. You never know, so I like to honor the user's number of significant digits, but let's see. So that seems to work. Now going the other way. So can I write this in a way that would be less hideous? Let's see. Maybe just this. Convert feet to meters string. How would that be? So we take the arg in feet and we return so yeah, we can do all of that. There's the number of meters, which is the arg feet times meters per foot. Then the return value is this function calling with meters, and let's see, that's there, and basically there we go. And if you will listen to me, it is slightly less hideous, and we can reuse it. So all we say is this edit train elevation minimum in meters is the convert feet to meters string, like that. And I guess we can save a couple lines here. Alright, if we go the other way around, we will be going the other way around. Convert meters to feet string. Worthless feet, but can't believe they use feet in aviation, but that's what they do. So the number of feet is equal to the number of meters divided by the meters per foot. We'll keep the ratio the way we wrote it because it's precise. The other one is probably not precise or exact. And anyway, so now we convert that using the meters here, using the feet here because we're converting to feet string. We keep the number of significant digits we had before, subject to some minimum. We can even add 1 to the number of significant digits because feet are less precise than meters, or they are smaller rather. They're actually more precise, but anyway. And this one, convert meters to feet. Except we need to get the meters value, don't we? Get the meters value, and then this is the feet. Let's see how it works. If I can get it to compile. So 1,000 feet is 304.8 meters, and 305 meters is 1,001 feet. And that's, we got 4 digits just because there was no decimal. But if we said 0.1, we get the same thing, 0.11. Add enough on here and we'll get whatever. So anyway, if you clear it, there's another thing I should do. Or blank. How about this? Otherwise, or blank, and if the arg meters is null, otherwise, and .val. So what we'll do now is we'll just, if we can't parse it, we'll just make it blank in the other field. So if we get a null here because we couldn't parse what the user entered as a real value, even though the user was making changes but we just couldn't parse it, he will get some feedback right away that we could not parse it because the other field is going to go to 0 or go to blank. So let's see how that works out. So 1,000 here, but then if I clear that, I lose them both. If I say 900 meters, 2953 feet. Okay, right. Right. So I think everything there is working how I would want. And then we can do the same thing for this. So that's pretty simple. It's really just this and this, but replace minimum with maximum. And just have a look. as we keep on trucking here. So 10, 100, 4,000. All right. Well, the next thing, we need to fix the tab order of everything at some point, but the next thing, as we just kind of flow through this interface, is this list of instrument configurations. I just want to show the user a summary of what is loaded in. And I'm thinking just a paragraph form summary. So we will need that as maybe a list utility. I have a function here that holds some list utilities. And let's go ahead and add one utility. Function convert get summary paragraph, one line per instrument. With taking a list of instrument configurations, we'll return some text. And we want to loop over our list and figure out what goes on each line. So let me just say maybe the instrument itself, the instrument configuration itself, maybe has a toString. Maybe it has a line string property. And what's gonna be in it? If this instrument type is a laser scanner, then return, they're all gonna be the same here, but then just field of view, total field of view maybe I should say. And maybe that's 4 digits precision. We add the total field of view. And what other parameters are for a laser scanner? The points per second. After a tab, perhaps. Kilohertz. Again. If laser scanner, points per second. And if beam divergence, otherwise, beam divergence, So what do you think about all of that? It's just getting a string representation of our instrument. Hopefully it'll sort of look okay. The code here certainly looks ugly, but otherwise, then the relevant parameters are, you know, why am I doing that? I should just be saying the instrument name. Instrument name should be enough. Plus the other stuff. The total field of view for the camera. A cross-track field of view, I should say total cross-track. Oh, maybe I'll build them up. I sort of wanted to avoid doing it this way, but build them up with a string builder with a buffer, basically. What does it not like here? Well, tell you what. The instrument name. Then, if we are a laser scanner, we append the total field of view. And the kilohertz. Did I grab it from here? Oh well. And if it has a beam divergence, then a beam divergence. Beam divergence. So whatever it was complaining about back here, guess I'll never know. Otherwise, if it's a frame camera, we need to append some different things. We need to append the total across track field of view. Sorry, the function has such a long name that I keep calling, but that's the name, that's what it is. If camera, total across track field of view. Yeah, I should finish that with degrees. And just finish this with degrees. Right. Total across track field of view. Non-pixels across track. I'll call it X. It's probably X. the num pixels. And then if we have these other parameters, we can specify them too. Total along track. Total field of view along track. As well as num pixels in Y. Could just have one, we could say resolution, and just have like 123 times 123, but oh well. Num pixels in Y. If frame camera num pixels. So that's all of that. One more. Sort of similar. If it's a push broom camera, then what is it? Total along track field of view is all we have. That's in degrees, isn't it? Well, for the moment, that's what it is. Milliradians would actually be better, but let me make my program compile once again, because I want to look at something. Let's see, let's just else unhandled enum then where I'm building my paragraph, just add each one with its line string. Complaining about something there. And here. And here. So I want to come back and look at the fact that we defined push broom cameras to have an along track field of view specified in degrees. And it's probably more likely to be specified in radians because, or milliradians, because it's going to be a very small number. It's the field of view of one row of pixels. It's the field of view of one pixel, really, in the direction the airplane is traveling. And that's just the way the push broom camera works. You know, push broom camera, instead of a regular image where you get a frame and there's a bunch of pixels in both X and Y, with the push broom camera you just get one row of pixels, and then the airplane flies forward and you get the next row of pixels, and hopefully your exposure rate is set properly that it covers the ground, you know, in a coherent way without gaps or too much overlap between one row of pixels and the next, but point being, the field of view in this direction the airplane is traveling is really small for a push-broom camera, and it's probably more likely to be specified in milliradians. But right now we have it in degrees, so I'll just continue with it in degrees and maybe revisit that at some point. We have our function that makes a paragraph summary form, gives our instrument list in a paragraph summary form. So now I would like to use it, and really we'll do that whenever our list of instruments is updated. And what we'll probably end up doing is just having a refresh form function that we call whenever the list of instruments is updated. But let's see. So that happens, and the text box. Let me go ahead and just make a local reference to our list of instrument configurations. Equals this guy. With our wordy design constraint that you can read this, but you can't write it. Don't modify it. Then the text on this instrument summary is equal to list util get summary paragraph, and the combo box refreshes itself with the list of instruments. Let's see how that might look. Okay, and if you make this wider, you can see laser scanner with a certain field of view and a certain kilohertz and a certain beam divergence. So it's not terrible, it's not a bad summary, I guess. If I then give this an along track field of view, let's see what happens here. Pow! Now has an along track field of view and a num pixels y. Well, that's pretty much all I wanted. It's just so the user can see what he has defined, and it's fine with me. Moving on, we need to make these synchronizations work. I don't know why that keeps coming back. I keep turning that off, and it keeps coming back. That doesn't look so great. Maybe a restart of Visual Studio. So yeah, keeps bringing back the scroll bars on this. I don't want it to now. This is a subclassed text box, and by default I set it to have all the scroll bars, but in this case I want none. Do I have to do it programmatically, or will the designer honor my decision here? Well, they seem to be coming back, and if I just close this and reopen it, they're back. So what can I do? I really don't know why that is, because all I'm doing is in my text box, custom control, scroll bars, both. It's in the construct function, but that only happens when it's constructed. I don't mess with it after that. So something specified in the designer window should honor that. That's silly that it doesn't. But I guess we have to do this ourselves to a certain extent. So now have they disappeared? Okay. So the next thing to hook up is this, for example, then this and this, so let's do it. I'll just add in a block of code for mode 1 logic. And mode 1 is going to handle when this gets changed and when this gets changed, when this gets changed, and when this gets changed, when this gets changed, and when this gets changed. That should be all. So it goes in my little block that I've set aside here. And so knots and kilometers per hour. We need another conversion ratio. I guess I'll gather those up somewhere central. Maybe way up here at the top. Conversion ratios. Meters per foot, and now we have kilometers per hour per knot, for example. Actually, there's knots, and there's meters per second, and there's kilometers per hour. And you know what? I kind of only want to bother with providing maybe... Should I provide a third? Is there room to provide a third? So, knots, kilometers an hour, and meters per second. I guess it's more likely to be specified in knots. I'll use this one as an optional way to specify it. And I will provide this as some sort of feedback, maybe just a label. Oh, I don't really care at this point. I'm just gonna put it maybe here. One label. So anyway, the exact conversion, let's go see. I always forget. What is the knot as a unit? It is exactly 1.852 kilometers per hour. All right. Exactly 1.852 kilometers per hour. So that's great. That's what I remember. Not entirely just trusting Wikipedia, but yeah, that's what I remember. Kilometers per hour per knot. 1.852 is it? Let's see. Times the 1,000. Let's see, meters in a kilometer. Divide by 3,600 seconds in an hour. So that would give, if we are 1 knot, it's 1.852 kilometers an hour times 1,000 divided by 3,600, 0.51 meters per second. So yeah, that should be right. That's what Wikipedia just said here, I guess. 1 knot is 0.51 meters per second. Okay. As an event handler, there's a little sub refresh function. So all I'm gonna do, so make these work in a way similar to the way these worked, but I need some new functions, don't I? I guess these could go up to our conversion ratios. That would be okay. Now we've got convert knots to kilometers per hour. Well. I don't know. So the arg in knots. Per hour. The knots times per hour per knot. And then correctly, and then how's that? Then convert km per hour to knots. It's an argument of kilometers per hour. The argument's null. Divide by the ratio this time. Convert that and take that. And while I'm here, I'm going to write one more, which is convert knots to meters per second. Convert knots to meters per second string. Meters per second. The knots times the ratio. Meters per second per knot. Then take this here and this there. So that will be nice. And in our refresh form function, what I'm going to do is if we're in mode 1, well, tell you what, I'll just do by default. Mode 2, flying speed knots, else if calculation mode 3, checked, edit mode 3, otherwise by default this should have been knots. So since we have our speed entered 3 different times depending which tab the user's in, I'm just getting whichever one is effective at the moment is being displayed. I could have done the test by the tab panel, but I chose to test by the radio button. And from that, I want to say that the... what did I label that? Label readout. Equals convert knots to meters per second string. How's that? The current flying speed is... why don't I say this? It's in knots, just make it clear. Otherwise, we'll have a little message. Just, I think it's useful. How's this? Ho ho ho. Knots to meters per second string. Rather. Flying speed of however many knots corresponds to however many meters per second. And I think I will size that to be an auto size thing. Rather, just do it like that. How will that look? And did we finish down here? No. So let's do it. Flying speed knots from mode 1. And we set flying speed kilometers per hour by converting knots to kilometers per hour. Alright. Then the other way. This edit box goes here. That edit box goes there. And we convert the other way around. Let me just see if that was all done correctly. Oh, and refresh form. And the main refresh calls that as well, right? Yes. Did I compile it? One more time. So, if I enter a flying speed here of 100 knots, it's 185 kilometers an hour, which is 51 meters a second. That's not bad. That's pretty good. Good enough for me. So moving on, flying height. And now I'll need to be parsing. It's common to both mode 1 and mode 2. So, flying height. Here above sea level, it's just another simple conversion. similar to what we did here. You know, let's see. The feet, we get the value in feet from mode 1, flying height, feet. Then we set the edit box, which is mode 1, height, meters. Convert feet to meters, meters to feet. So just take this here and this there. So that should work fine. Now what we need to do is, let me make a little text box for it. Maybe a new refresh form function for it. So what is this? It is height feedback. So just for every group box, which of the two, where the user specifies a flying height, what I want is, I suppose, to get the flying height. Guess I'll grab it in feet. So flying height above sea level in feet is equal to our edit box from mode 1, flying height above sea level feet as a reference double. If it's null, then just clear those boxes, or clear the feedback for text mode 1. Otherwise, we need to figure out height above terrain. So min terrain height in feet is equal to edit what's the deal here? Edit terrain minimum elevation feet and the max terrain elevation. So feedback text, this text mode 1 equals feedback text. So if we have a min terrain height entered, user should probably enter both. We'll probably not calculate unless he enters both, but for now we'll say if he has the min entered, then we will provide the height above that. Above min terrain, flying height of min terrain in feet equals flying height above sea level in feet minus min terrain height in feet. And I'll also convert that to meters. Well, let's just see. Feedback text. We have our text box. We're just going to say inside so many feet above sea level, flying height of flying height of flying height above min terrain feet. Let me make it a proper string. Let's see. Height above min terrain feet string equals the value and the number of significant digits. In the flying height above sea level value. There's our number of significant digits, and let's see. Oh, right. Num digits. And flying height above min terrain meters string. This times some conversion ratio. So flying height of so many feet corresponds to this many feet this many meters above min terrain elevation, above lowest terrain. We'll just have to see how this looks when we run the program. All the mins here are going to be max. Flying height above max terrain equals max terrain height in feet of max terrain, flying height above max terrain feet meters. Above the highest terrain. We will also need event handlers for when the user is editing the terrain parameters. We already have handlers for when the terrain values are being edited. We just want to call this new refresh form function. Refresh the height above the terrain feedback. compiling state. And did we call that function here when he edits the height? When we edit the height, also call that. And when you refresh the form itself, go ahead and call our new function. For the feedback, for mode 1 at the moment, we've implemented it. Alright, well if the minimum terrain is 1,000 feet and the max terrain is 1,200, maybe that's the right tab order, I don't know. Then, flying height above ground, let's say, is 6,000 feet or above sea level. Alright. Flying height of 6,000 mean sea level corresponds to 5,000 feet above the lowest terrain, 800 feet above the highest terrain. Maybe I should just get rid of this part. Flying height corresponds to flying height. Whoops, that's not where I want to be. Flying height corresponds to flying height corresponds to. It's okay with me. A little redundant, but that's okay. And you know what else I'm gonna do real quick is auto persistent values. Let me add one thing to my refresh form to synchronize the selected tab with the selected radio button. So in refresh form, if the radio button mode 1 is checked, then this tab goes there. Else if mode 2, go there. Else if mode 3, go there. And we do call refresh form when our program initializes, right? No, so we need to add that. Now what I'm going to do is make the program remember the values we have entered previously for most of these fields. So I can do that conveniently because I've subclassed the user interface elements, and all I have to do is turn on a property to say go ahead and remember the value. So it's called bool auto persistent value. I will turn it on, and I suppose there's no reason we can't remember, in fact, most of the program settings. Maybe not that one. I don't think I implemented auto persistent value for combo boxes. Maybe I should. Maybe I should. For the moment, we don't have it. make a little to-do combo box. To-do add auto persistent value string representation. Well, anyway. So now, if I go in and I go through the trouble of entering terrain elevations, say 1,000 to 1,300 feet, then if I close the program and open it again, we should get just the same back. I probably want to call the event handlers for this to make sure it stays synchronized. I don't know who's gonna mess with the XML file to make these go out of sync. I guess it's okay. But as we were saying, if our flying height is... That was not so good. Why don't these synchronize? Mode 1 logic. This should be mode 1. Since we're looking at mode 1 logic. So let's see. The other thing I want to show is, for example, if we select radio button 2, we're in mode 2, and close the program, and reopen it, we should go back to the second tab, which we did. We'll stay in mode 1 and just say, for flying height. Now, why is that? Did I add the wrong handlers? That looks right. Why? It isn't getting called, though. Why is that? There it is. So you should call when you change. What's going on? Okay, good. Okay, I have no idea what that hookup was, but... So, if our flying height is below the train, maybe we should just say that rather than give a somewhat nonsensical message. And I guess I don't want a third new line character. It's really just a third line. So refresh the height above the terrain feedback. Rather than using append line here, I'll just use append for the second line. And we will, if it's negative, if flying height above terrain, if it's negative. Rather, it's like this. Flying height is below the min terrain. And for max, same deal. If flying height above max terrain is less than 0, else, flying height is below the max terrain. How are we gonna look? Flying height's below the min terrain, flying height is below the max terrain. See what we can do about that. It's a little nonsensical, but that's okay. 6,000. So that's alright with me. Now, flight line separation, synchronization. That's easy enough. Couple more things here. Mode 1. Flight line separation, which comes first? Meters is first. So get the value and set something on the kilometers. So here's an example where our handling for significant number of digits is good. Separation in kilometers. I guess I'll go ahead and write this function. It's gonna be convert, meters to kilometers. String or blank arg meters. Otherwise, kilometers equals arg meters divided by 1,000. With the number of significant digits as we had in our meters. Somewhat conversely, just having a look at what functions I have. Feet to meters, meters to feet, meters to kilometers, and then kilometers to meters. Right, that's what I just did. Kilometers to meters, arg kilometers, and one more. Meters equals kilometers times 1,000. So there are our two functions. Coming down to here, we say convert meters to kilometers. We don't need that. Otherwise, we go the other way. We say this goes here, and this goes here. And from This we say kilometers to meters. We'll just have a look at that. Thousand meters is, let's look at that again. 0 kilometers. I guess minimum number of significant digits should be 3, because it's interesting, all the subtleties here. I wish I could spend the time to write a nice library to handle, it's like a change of scale. It's like keeping precision over a change of scale. But what I'm just going to do is say minimum 3. It's just so the user sees that the feedback is working correctly, even if it's a little bit nonsensical as a value, but you want the feedback to be working right. And I guess the other way. Still. That would round to 3 decimals, right? But it would be 0.001. Yeah, I don't know why that doesn't work. Let me set a breakpoint here. Just go ahead. Alright. 1. The number of significant digits in 1 is 1. Then that, or 3, is 3. Then 0.001 rounded to 3 decimals, it should say. Aha! I'm subtracting 1 there when I don't want to. I guess just special handling if it's 0. If the int part is 0, then don't do it. And that explains some little things I saw when we were looking at some of the other conversions. Where are we? If the int part is in fact 0, then the num digits in int part is effectively 0 for present purposes. Yes. Alright. So 1 is like that. What did I just do? And then if we're 0.3 kilometers, it's 300 meters. And 100 meters is 0.1 kilometers. So cool. So that takes care of our, synchronizing the inputs for mode 1. And I guess I can move along to mode 2. So if we are mode 2, we just do some similar work. I need event handlers for this and this, this and this. I guess this isn't going to be relevant to as far as an event handler. Oh, nor this. So it's just 4 event handlers for mode 2. So, mode 2. Excuse me, mode 2. This is odd. There we are. Text changed. But you're not in the mode 1 logic. I want to kind of keep this tight as a block, so I'll just do that. Now we've got mode 2 logic. Fix that later. That, and that, and this, and this. Oh, well, that did actually go in the right places. Let's see. So these handlers are really just the same. Flying speed, flying height means sea level. Flying speed, flying height means sea level. I should just be able to replace the mode 1 to mode 2. I should get the exact same function spec. That's one of the reasons why I brought out these text editor to make sure I was naming things consistently. Earlier when we did that, I just want to replace mode 1 with mode 2. Replace in selection. This is still the right function, right? If we find references. Yep, it's being referenced in the designer. So that was fairly easy. Should be correct. I'm just gonna have a look. And I need to update this function because I didn't implement it for mode 2. So let's do that. The only difference being that, I'll use the text box. You would really only need to refresh the text box that is visible at the time, but I'm going to do it for both regardless, and it's sort of a copy and paste operation, which I don't really mind or don't really care. It should also be very straightforward. Mode 1 to mode 2. Let's see. So that's what it is. Let's see. So now if we're over in mode 2, we say we're flying at 10,000 feet. That corresponds to 9,000 feet above the min terrain, 8,700 feet above the max terrain. And these look reasonable as well. So let's say, if I copy this, put it in here, one, 296.2. I should be exactly 1,000 above, but I'm not because of rounding when I convert to feet, but that's alright. It's okay with me. Otherwise, you'd need to just remember which edit box the value had been entered in, and there's no sense in trying to keep that much bookkeeping. So what's next? Let's see if this works. Looks like it works. Mode 3. Flying speed needs to stay synchronized. And this other stuff is gonna be complicated. Well, I guess not too bad. So let's work on it. I'm going to pause the video one moment. And we're back after a short break. So I was just about to start on synchronizing up the fields on mode 3 here. So starting with flying speed and then resolution and so forth. So flying speed should be pretty straightforward. Go over to mode 3, add our flying speed handlers. Which will go in a mode 3 logic block. Aww. Oh, I lost them. There they are, they're back. So this is just the same as the other knots to kilometers per hour handlers, but with mode 3 this other stuff, I need to start looking at it from the perspective of the refresh form operation. So when I refresh this, and it's going to be based on what the user has selected here. So this needs an event. Selected index changed, item changed. Selected index changed. And I think it's going to be a new little sub function from our refresh form set of functions. Where are we? Refresh form. That was a long one. Mode 3. I'll just call it that, refresh form mode 3. Some special logic here, which will be called whenever we do a full refresh as well. And will be called in this selection changed on the combo box logic. And what we want to do is see what type of instrument we have selected. as an instrument configuration. And if it's null, then I guess there are no units, are there? So this label on the right hand side, edit mode 3 for the units, has no units. And we might hide one of these. I may hide this one because it only applies if we are using LiDAR. How should we structure this? I'm just thinking about our cameras again that have possibly non-square pixels. We could say this is pixels X and this is pixels Y. Pixels across track, pixels. I need a little more space for my labels. And let's see. If the selected instrument well, if the instrument type is a laser scanner, otherwise, well, if it's a laser scanner, then one of these. The point spacing for LiDAR is centimeter point spacing, for example. And points per square meter. Yeah, I need quite a lot more text. Maybe I collapse these into 2 lines. Just get them out of the way for the moment, I guess. Or what do I want to do? I just want really to copy their text. There's one. There's another. And now they have no text. And these are similar to what I want. This has the text from the first one. This has the text for the second one. We'll make them the same size. Oh, let's see. Should I just put these a little closer together? At best, at worst. It's what it is. So is that gonna be an all clear? Centimeter point spacing and points per square meter. In which case, let's otherwise, what I'm thinking about saying is pixel size for cameras. Let's see. Pixel size across track. And then we'll have pixel size along track. So I can rename these to specify what they are. Point spacing for LiDAR. And pixel size across track for the camera. And pixel size along track for camera. Points per square meter for LiDAR. All right. So yeah. And then as far as doing the calculations, I guess what I would say is if it's a camera, bool camera has two axes, has all I really need to do is this. Pixel size along track. If may add one more property. If camera Public bool if camera bool has pixel information in a long track direction axis. This user may optionally provide this or not. So if instrument type is a frame camera and we have these two, then return true. If our instrument type is a push broom camera and we have this push broom camera this value, then true, otherwise not. So if we are a camera and we have information for the pixel in that direction, then we'll set the label for that. Otherwise, we'll set the text of that box to nothing. And we will hide the label and the text box. Well, text equals nothing and the text box is hidden. Otherwise, the text box is visible. Guess, and is visible, and is visible. It's not super great logic, but oh well. So where does that put us? And index is changed, we do that. As well as, well, we do a full refresh if the set of instruments changes, don't we? Yeah, we do a full refresh if the instruments change. So event handlers for changing these boxes, I guess? Because if it's LiDAR, then one corresponds to the other. And if it's, also if it's camera, then one corresponds to the other as well, if you have the information for both. So we need handlers. Just check. All right. I should probably, well, I'm worried about the value staying. If I have a value here and then I change my instrument type, maybe I should clear the value because he might be changing instrument type. And then the meaning of the box would be changing but not the value, and it might not be great. But I guess I'll leave it for now. Well, I should do what I just mentioned. So let me see. If you, let me do it this way. Do I have access in my combo box Okay, mode 3, previously selected. Do I have a previously selected item? In the combo box, prior selected index. Okay. So, how does that work if it's a full refresh? If the thing is just getting refreshed, do I get a selection changed event? I mean, right, in the refresh form. Where's my refresh form? This one should refresh. And when I do this, I don't want the event handler to fire, because I'm just not sure. Where are we? Enable selected index changed? What is this? Okay. Just couldn't really remember what we were doing. Oh yeah, we were working on the tab panel when we added that logic. So the combo box already has it, which is great. And I guess I call it stack to say that you should put it back to what it was if you modify it. So don't. That's interesting. Alright, well. Prior setting equals. Maybe I should just say without event. Well, it's really just here that I don't want this event. I'm going to have some special handling here that looks at the previously selected item, and if it's not the same type as the newly selected item, I'm going to clear the text boxes. And maybe I'm getting too far ahead of myself, really. So, tell you what. Just let it do what it wants to do. And say if the prior selected index is not null. See, this is what I'm thinking of, is that if we are refreshing the list, then this will no longer be an accurate description of what the prior instrument was, because we are referring to it by index and not by object reference. Maybe what I should do is go in and also maintain the object reference, because that is how I could make an accurate comparison of instrument type. So maybe that's what I should do. I just need to store both. And anywhere that this gets set, I also do my other guy. Let me add a comment about why I added him. Added GSC 2016-11-04 because we had occasion to. Because when refreshing list, previous selected index may not refer to previous selected object, was my concern. This previous selected object equals what? This selected item. Guess that's all. Then in the derived class where it's templated, in the derived class where we have a template type, or a generic type rather, I can just say how's that? It's a little bit literal, but and even though it's called private, I'm just accessing it. I guess it's more of a indication that I shouldn't modify it. But let's see. If the previous selection is not null, and the type is different, let's say if that's not null and the current item is not null, and the type is different, here's my selected item as T basically, so I'll use that here just for consistency. Instrument type. So if they're not the same instrument type, then I should clear the values in that box because they just aren't gonna work that great. Why do I have two things here? What is this and what is this? Edit mode 3. That sounds right. Oh, it's a text change handler. Stupid thing. Why would I care about a text change handler? Then we're gonna clear it. Otherwise, I guess at least make them consistent. So we should trigger the text changed handler for one of them to synchronize the other one. So for example, let's just fire the text changed handler. In this case, I do actually want the text changed event. We'll just manually trigger the text change event for the top field, which will synchronize the bottom field when the user changes the instrument type so that they stay consistent. And yeah. So if the user changes the text, then we need to figure out what to do. So if our current mode so let's just pull out an instrument configuration, selected instrument equals combo box mode 3, selected item, and if it's null, then let the user enter whatever he wants in the current box, but probably clear the other box. Edit mode 3, desired set text. Otherwise, if the selected instrument is a laser scanner, come on, where did I go? Instrument type. What? Now look at that. Did you see that? Instrument type. It's right here. If I press tab, it's going to a 2-string. Maybe because I was going quickly or something, but anyway. If we are a laser scanner, then do something. Otherwise, if we are I'll just handle it as an else case. So if we're a laser scanner, this should be somewhat easy. We're just going to say convert between point spacing to points per square meter. So I may keep in form with what I was doing and say points per square meter. Convert point spacing to let's see, point spacing centimeters and centimeters to points per square meter. Arg point spacing centimeters or blank. Otherwise, points per square meter, let's just say local point spacing in meters equals arg point spacing in centimeters, divide by 100. Then the points per square meter is going to be 1 divided by this squared, I guess. Point spacing, so if it's a point every 10 centimeters, which is 0.1 meters, then you'll have 100 points per square meter, and you get that just by 1 over the square Guess I have to use my own. The square of the local. Just for clarity, I guess. Why is that a problem? And then regarding number of decimals precision, it's however many decimals were used here, but at a minimum 2, I guess. Points per square meter. Minimum 2, so you might have 1.1 point per square meter or 10 points per square meter. Then the other way, convert point spacing in, you know what, I want 3. What can you say? I just want 3. The other way around is convert points per square meter to point spacing in centimeters. These are strings. So the arg, points per square meter, if it's null, return a blank. Otherwise, local point spacing meters is gonna be, I need to take the square root and I guess take 1 divided by that. So let's see. If we have 100 points per square meter, then the square root of that is 10, and 1 over 10 will give us the 10 centimeter point spacing, or the 0.1 meter point spacing. So then we have local point spacing centimeters is just this times 100. That's what gets converted to a string with the appropriate number of decimal places. So let's use them. Text changed. If we're an instrument, then just say that the value is coming from edit box 1, mode 3, and edit box 1 is point spacing, centimeters, this edit box, point spacing, centimeters, then in the units 2 box, set the text to convert point spacing in centimeters to points per square meter from the value. That should do it. And going the other way, we say that this goes here and that goes there, and we convert the other way, and it It's clear from the name. Points per square meter for LiDAR. So let's see what we have. If I enter some resolution, it's just not gonna sync because actually I think I put the text box wrong. Yeah, here should be number 1. Right. So, if I'm entering something here but no instrument selected, then it has no idea what I want. If I select a laser scanner, then we see enter here the centimeter point spacing, or here the points per square meter. So if I want 50 points per square meter, that is a 14.1 centimeter point spacing. Or if I want points spaced every 20 centimeters, that's 25 points per square meter, which makes sense. 10 points per square 10 centimeter point spacing is 100 points per square meter. Let's see. So pretty much that works how I wanted it. And if I change this to say a camera, it should clear the values because they no longer apply or make sense. And yeah. But if I had 2 laser scanners, hypothetical laser scanner number 2, and I enter something here. If I change this to this, it's okay. What's next? I guess if I wanted to make this work at all, where I synchronize the across track pixel size, so I can take out the train variation by the fact that the triangles just, scale geometrically. So what I can say is that I guess this is pixel size in centimeters. So if you know, if the field of view of 1 pixel, what the heck? Why is my paint so messed up? Oh, that's interesting. I didn't know you could hide that. Still seems messed up. Oh well. If I have a camera where the field of view of a pixel on the x-axis is like this, quite exaggerated if we're imagining it's just the field of view of 1 pixel. But then let's say the field of view of 1 pixel in the y-axis is like that. If I want a certain point spacing, and we're going to solve for the height that will achieve that point spacing, but if I want, 5 centimeters point spacing for that, for example, for the across track resolution, we can figure out what the corresponding resolution would be for the along track. And the way to figure that out would be, well, some trigonometry with a imaginary height, perhaps. Just say that the height is 1, and let's see, the so we do need to use the tangent. So the tangent of this angle will give this over this, and if this is 1, then the tangent of the angle will just give this. And then we have the other tangent, which is this other ratio. So we'll have a ratio of the tangents, which would be, for example, this is x and this is y, and then we can scale by that ratio to figure out that, for example, 5 centimeter resolution in this will correspond to 10 centimeter resolution in the other. And we don't even have to bother multiplying by 2 or anything, because it would just work out. It would flush itself out because the ratio is the same between the two. So let's do that. So if you are a camera, and I have specified, I'm probably going to add this as some properties of the instrument configuration. So for example, this is going to be, if you are a camera, if camera with pixel information in both axes, footprint ratio are of pixel size x over pixel size y, where x is the across track dimension. Guess that's clear enough. And so we assume that we have, if the instrument type is a frame camera, otherwise we must be a push broom, otherwise programming error, don't call property if not camera. Don't do it. This can somewhat upset the debugger if you have automatic property evaluation set, but I usually turn automatic property evaluation off. Let's see, if you're a frame camera, then we'll just assert that you have the parameters you need. So field of view of the nadir pixel. Okay, in radians. Let's do this as well. If camera with along track pixel information. Along track nadir pixel field of view in rads. So if you are a frame camera, otherwise, or a push broom camera, Otherwise, for a frame camera, our field of view. Yeah, well, this is easy. If it's a push broom, then that's what we store. It's just the if push broom camera. The field of view along track, because it only has one pixel along track. Otherwise, we do these same calculations. Half field of view, but everything that is across becomes along. Camera, total field of view. If frame camera, total field of view along track, value. Then we take the tangent, and then that's the sensor size, and size on sensor of 1 pixel. If frame camera, num pixels. And then we just go ahead and do it. Field of view of the nadir pixel. It's taking an arctangent from the size of 1 pixel. So yeah, that all still looks right to me. So now, if we're a camera with pixel information in both axes, we want the ratio. So now we've written it so where we can just refer to this. Let's just say along track nadir pixel field of view equals, well, if camera across track, so across track field of view in radians, then along track field of view of the nadir pixel. If camera with a long track quick fluid, a long track nadir. So there's that. I guess I'll take the tangent of both. Tangent. You know, I'll use it from my own trig library so that it's clear about the units. Just want the tangent in radians. Cross becomes along. No. And that's pretty much the ratio, right? As if the imaginary cosine component is the same, then these can multiply that out. You'd have the sine component, and that was the ratio we wanted. So we just say, let's say the across track divided by the along track. So now we can use this in our text changed event handler when the user is editing the resolution he wants. If it's the pixel size for camera, so I had given better names to these, and I'm going to go pick them out of the designer because I was naming the labels, and I want to apply the same naming to the text boxes. So here we are. If we are the first edit box, then you are the pixel size across track for the camera. Otherwise, you are the point spacing in centimeters for the LiDAR. So the corresponding thing, let's say pixel size centimeters as well. Pixel size in centimeters and pixel size centimeters. Now I want to take the same name convention and apply it to the edit box. So where is that? Edit mode 3, desired resolution units. Edit mode 3, desired resolution. There it is. There's number 2, so here's 2, it'll match. And please do rename that. And then here, go here and rename it. Great. So now we should know what's what by looking at the variable names. Now, here are our event handlers, this one and this one. If we are a camera, then if the camera has information for each, if the camera has information, instrument type, otherwise just clear the other box. And we have the information for both, so we've edited the across track. I want the handlers to have the same names. This is the name. Please rename it. So, it's the pixel size in centimeters across track for a camera. In which case, if we have the information for both cameras, we say we'll set the value for number 1. So, just cross track pixel size equals this. Edit mode 3, box 1. Should really just say positive or null, huh? Make it positive. If the across track pixel size is null, then set the other box to nothing. Otherwise, set it to the ratio, and that's going to be the selected instrument cross over along equals selected instrument x over y is the cross over long, and along track pixel size equals the across track pixel size value divide by that ratio. Then I want to do our trick of getting convert to string using number of. I want one more library function. Convert first argument to string using num significant digits of second arg. Subject to minimum. Subject to minimum. arg3 minimum. arg3 digits. Oh, heck. Convert arg1. Convert first arg to string using num significant digits of second arg, subject to minimum digits argument number 3. Specified by arg3. Arg val reference val arg minimum num digits precision. So num digits precision equals get num digits in the reference arg, then return toString with given number of significant digits for the argval, subject to a minimum, which means choose maximum. Value or minimum, which is num digits precision, arg3. How's that? There's arg3. So there it all is. It's effectively what we were doing a number of times. Didn't like it. There it is, anyway. So, where are we here? We want to say this set at mode 3, box 2, set text without event is equal to our wtil, the function we just wrote, which is the along track pixel size, using the across track pixel size as a reference, subject to, let's say, minimum of 2 significant digits. Then it's just the same thing in this other case. Except you have to be careful and swap everything. Across becomes along. Cross becomes along temp, let's say temp ASDF, along becomes across, and temp ASDF becomes along. So now we have the along track pixel size equals the box number 2. Then if it's null, the box number 1 gets set to nothing. Otherwise, we get the same ratio, and we say that the across track is equal to the along track times the ratio of along over across. Then we say that box number 1 is equal to the across track pixel size. So that worked. That's actually correct. Otherwise, the first box just becomes 0, but this would really be an assertion failure because the user shouldn't be able to enter the text here if he doesn't have pixel information for both axes. But that's okay. So let's see if I got all of that at all working sensibly. So let's have a situation where our camera, maybe it has the same field of view in both x and y axes, but only half as many pixels in the y-axis. And that would result in the resolution being quite different, just by a factor of 2, so that's what we want to check if we are able to pick that up. So if I select a camera, now that was interesting. It knows that pixel size of 10 centimeters. Why don't I do that while I'm thinking about it? Label it track field. Where is it? Mode 3 refresh is where it is. Mode 3. Pixel size. Centimeters across track. Pixel size, centimeters along track. So, if we have an instrument selected, do we need to refresh mode 3? Oh, our text box needs to be a little bigger, or our label needs to be a little bigger, but let's see. If we have a 25 centimeter along track, then that's 12 centimeters across track. I want 3 digits minimum. What can I say? That's what I want. I want 3 digits minimum. That's pretty cool. Who but myself makes user interfaces this way? Puts this kind of painstaking attention to detail. Whether it's a good return on investment in terms of the time I put into it, who knows? Let's see. This should just actually do nothing, clear it out. That'll probably set it to nothing. But, you know, 9 here is 4.5 there, 25 is 12.5. And what else? What else? When you click these labels, it needs to highlight the radio button. These need to only be visible if you have a LiDAR instrument selected. Need to assign the text for that button. So let's see. Oh my gosh, what just happened? Can I undo? What happened, honestly? Oh, I guess that's where we are. Something happened at some point. That's not the right height. Don't know why that got messed up. Guess we are okay, thankfully. Maybe I'll make the group boxes the same size, at least in Y. 154 is the size of it. And this is size 36, and this is size 36. Well, anyway, I guess that can come up. What's the location here? Position 82. Is it? Alright. So mode 3. If you click one of these labels, oh, my labels need a label name. Alright, so if you click these labels, the corresponding radio button needs to be selected. And let's set our button info box button equals this. Oh well. So let's see, we're still in mode 3 logic, good. Just put these all together. If you click that radio button, then this radio button, it's really from there to there. Checked equals true. If you click this one, checked equals true. If you go and you click this one, well, looks like my name's changed. Checked equals true. And if you come over here, it shouldn't be called mode A. That's mode B, for example. What did I do? This radio is called, for LiDAR take multiple passes into account. And actually I've changed the way I'm working, so I don't need this to indicate anything for the camera anymore. It's just for LiDAR take multiple passes into account. We'll call that mode A. Or mode B. LiDAR, consider resolution from single pass. Consider resolution target relative to single pass. Anyway, maybe I'll rename my labels. This is the label for that. And this, you called it mode B, right? Yeah, it's the label for that. And these click events. Just anyway. Mode 3, mode B equals checked. And this is mode A. There we go. Let me just test those. So if we're over here and we click the label, it selects the right thing. So, jeez. At left, specify desired resolution to obtain with the instrument, and specify whether you want to achieve the resolution from a single pass of the airplane or whether, if the overlap is great enough, coverage from multiple passes may be considered so as to effectively increase the resolution. For example, if overlap is greater than 50%, total number of points per square meter is doubled with route to increase in resolution. Greater than 67%, the total number of points per square meter is tripled after considering overlap. Let's specify whether, relative to the resolution you wish to achieve, whether to obtain it from a single pass or whether to obtain it from considering multiple passes. Kind of wordy, but I guess it gets the point across. And let's just see. Whenever we refresh the form or change the selected instrument, if it's a laser scanner, you can see these. If it's not, then you can't. So, the mode 3 refresh logic. If the selected instrument is null, I guess we'll hide, or just leave it be, I guess. Otherwise, if it's a laser scanner, then the panel is visible. Otherwise, it is not. So, believe it or not, I think that just about covers what I wanted to do. Let me do one other example of if I have a push broom and I make up a long track field of view. For example, I don't know what's reasonable. Then if I say I've got my push broom camera out, could be. 1 centimeter across track is 27 centimeters along track. Probably because field of view is quite big if I say 0.01. Now, oh good, that triggered. I wasn't sure it would, but it did, I guess because we do a full form refresh. And what, was that a selected index changed event that did that, I wonder? I'm just curious. Is this what did that? Yeah, probably. And, well, I'm thinking about that kind of thing. What else needs to synchronize that way? If I update a instrument parameter, let's say I've got my laser scanner here and I've got my laser scanner there. If I have a certain point spacing, well, no, this doesn't depend on the instrument at all. Are there any other examples that might depend on the instrument? No, I guess it was really just camera resolution and the relationship between the two. And that seemed to update okay, so I will leave it be. And then if I change this to a camera, that disappears. So believe it or not, that just about fleshes out the user interface for our main form for this program. And I think I have quite run myself out of steam, so we'll save for the next session actually implementing this perform calculations button. So the user can finally set up his parameters as he wants, and then just click the button to get the report as to what he will achieve. So for example, you know, if you have a certain flying speed and I choose to get a certain resolution with my LiDAR, with a certain overlap on my LiDAR, then that's planning everything relative to the LiDAR. I'll click this button and I'll see what resolution and overlap I will achieve with my other instruments. So that would be one, for example, workflow of using this software. And you know, it would solve the height in order to achieve this resolution with the LiDAR. So anyway, click the button, get a report, but gotta save it for next time. So thanks, and see you then, perhaps.